This video is going to go over scientific notation and standard notation and how to convert numbers back and forth between both forms of numbers. The first one we're going to look at is scientific notation. Here's a couple rules that you need to know for making numbers in scientific notation. The first one is when the number is written in scientific notation, it must be greater than 1 but less than 10. So that is very important that you know. If a number is in scientific notation, the number is greater than 1 but less than 10. So while you're doing that, you're going to locate the decimal point in the original number. There's two T's. If there's no decimal point in the number, it's at the end. Okay. Once you know where that decimal is, then you're going to move the decimal point either to the left or the right, whichever way you need to, so that you can create the new number that is greater than 1, less than 10. Okay, second thing you need to do, count the number of jumps that you made when you move the decimal. I know that's something that people have said from elementary school. You count the number of jumps or the place value positions that you move your decimal point. Okay, that number of jumps will be written as your exponent. So I'm going to underline that. That will be written as the exponent, however many times you've moved the decimal point. So here's an example. If the original number was greater than 1, then your exponent will be positive. If the original number is less than 1, then your exponent will be negative. Okay? Really small numbers, this is so super tiny, it would be like a microscopic item. So it will be written with a negative exponent to show you then that it's a super tiny number. Positive exponents show you that the number is originally large. It would be greater than 10. Then the last thing we're going to look at is when you do get your final number in scientific notation, it's always written as a power of 10, which means it would have times 10 and then with the exponent. Scientific notation is always written as a power of 10, which basically means it will have times 10 with an exponent. Okay, we're going to try a few together in the video to get you going. Here is a real life situation. The distance from the Earth to the Sun is about 93 million miles. Write the distance in scientific notation. Sometimes numbers that are really huge like this are hard to read, so scientists use scientific notation to make it easier for people to read their numbers. The first thing I need to know is put the decimal point in the location so that the number is less than 10 and greater than 1. So if I put a decimal point between the 9 and the 3, that would be fitting category 1. Now I need to count the number of spots I would move the decimal point to make that happen. So if I go back 1, 2, 3, 4, 5, 6, 7, 7 jumps. So my exponent is going to be 10. It's always written as a power of 10, so I have times 10 to the 7th power. And this was a very large number, so my exponent is going to stay positive. My final answer for that would be 9.3 times 10 to the power of 7. Okay, the next one just gives you a number, 6,400. Put it in scientific notation. Step 1, put the decimal point so that you get a number less than 10 and greater than 1. So my decimal point would have to go between the 6 and the 4. My final answer is going to start out at 6.4. Then I need to count the number of place value positions or jumps the decimal would need to move to get to that location. 1, 2, 3. So my exponent is 3. Then it's always written as a power of 10. And because this number 6,400 was a large number greater than 10, then I'm going to keep this exponent as a positive number. The final answer for this one would be 6.4 times 10 to the third power. Okay, number 3, another real life situation. It says the average size of an atom is about 0.000000003 centimeters across. I have no idea how many place value positions that is, so I'm not even going to try. Write the average size of an atom in scientific notation. Okay, so again, step 1, put the decimal point so that the number is less than 10 and greater than 1. That would be putting it all the way at the end so that I could get 3 as my number. Second step is count how many jumps or place value positions you have to move the decimal. So 1, 2, 3, 4, 5, 6, 7, 8. I moved it 8 positions. And then scientific notation is always written as a power of 10. So I put times 10. Final answer would be 3 times 10 to the power of 8. However, this was a super duper duper tiny number. It's less than 1. Okay, so this is a very small number, which means my exponent needs to be negative. Negative exponent when the number is less than 1. Okay, and then the last one says write in scientific notation the number 0.000829. So this one, step 1, put the decimal point so you get a number that's less than 10, greater than 1. The decimal point would go between the 8 and the 2. So my answer starts out as 8.29. Step 3, count the place value positions or jumps the decimal needs to get moved. 1, 2, 3, 4. So my exponent is a 4. Again, this is a super small number, which means I need a negative exponent. And then everything in scientific notation is written as the power of 10. So my final answer would be 8.29 times 10 to the power of negative 4. Okay, now we're going to do the opposite. We are going to write a number in standard notation. So this is on the next page of your journal. And the 3 rules for this, we're kind of going backwards. The first thing we're going to look at is to let the exponent identify us how many jumps we have to move the decimal point. The exponent will tell you how many times to move the decimal. The exponent tells you how many times to move the decimal. So when you're looking at this, if this exponent is negative 3, it means the decimal point's going to move 3 times. If the exponent is 6, you're going to move the decimal point 6 times. Then the second thing you want to look at is the exponent itself. Is it positive or is it negative? If it's a positive exponent, then you're going to be creating a large number. So you need to move the decimal point to the right so that it becomes larger. When the exponent is positive, move the decimal point to the right because I'm trying to make a number greater than 1. Then if the exponent was negative, you will move the decimal point to the left because you're trying to make a number less than 1. And then, let's see, I'll go ahead, put these in. And now we're going to try a couple of those. This first one, it says platelets are one component of human blood. A typical platelet has a diameter of approximately 2.33 times 10 to the negative 6 meters. Write this number in standard notation. So step 1 is figure out how many times to move the decimal point. And this says 6. That's the first thing. And it's negative. So since the exponent is negative, I'm going to move the decimal point 6 times to the left because it was a negative exponent. So the number originally, right now, 2.33, I need to move it 6 times to the left. 1, 2, 3, 4, 5, 6. And then all those empty spots I fill in with zeros. 1, 2, 3, 4, 5. So then that would be my final answer. Point. There's 5 zeros. Okay, 0, 0, 0, 0, 0, 2, 3, 3. That would be the number written in standard notation. The next one says write 1.045 times 10 to the negative 2 or negative second power in standard notation. First thing, check the exponent to see how many times you need to move the decimal point. This says a negative 2. That means I need to move it 2 times to the left. Negative exponents mean you're making a super small number. The number started out as 1.045. I'm going to move it 2 times to the left. 1, 2. I only have 1 blank space, so I only have to fill in 1 0. Then the final answer would be 0.01045. Number 3, it says the mass of one roosting colony of monarch butterflies in Mexico was estimated at 5 times 10 to the 6th power grams. Write this mass in standard notation. Step 1, check the exponent. It's a positive 6. If it's positive, that means I need to move the decimal point to the right. So 6 times to the right. The original number was just 5. That means the decimal point would be at the end. I want to move the decimal point 6 times. 1, 2, 3, 4, 5, 6. Then fill in all the blank spaces with zeros. 1, 2, 3, 4, 5, 6. 6 zeros, so 5. 1, 2, 3. 1, 2, 3. That is 5 million. Final answer. And then question number 4 says write 7.034 times 10 to the 9th power in standard notation. Step 1, check the exponent. It's a 9. That means move the decimal point 9 times. And because it's positive, you're going to move it to the right. So 9 times to the right. And the number starts out as 7.034. Then moving it 9 times to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then all those blank spaces get zeros. This is a super huge number. Okay, final answer is going to be 7034. And then we have 6 zeros at the end. 1, 2, 3, 4, 5, 6. Putting in my commas. That number looks like it's going to be 7,034,000,000.